Welcome to my new tech video. Today topic is C hash to CPU. .NET Magic. Let's get started. Welcome to the fascinating world of C hash and net. When you write code in C hash, you're expressing ideas, not directly instructing a machine. But how does your code transform into a real program that runs on Windows, macOS, or Linux? Today we'll explore the net execution pipeline, revealing how your text becomes powerful machine instruction. Understanding this process can change the way you approach performance, debugging, and system design. Let's embark on this journey from C hash source to CPU execution, step by step. Writing C hash code is about expressing logic and structure, not issuing direct commands to hardware. Your code starts as human-readable text, full of creativity and intent, but for it to run, it must be translated into something the computer understands. This transformation is powered by the net ecosystem, which bridges the gap between your ideas and the CPU's requirements. By understanding this process, you gain insight into how software truly works and why net is so powerful for cross-platform development. You build your C hash project. The compiler, known as Roslyn, doesn't turn your code directly into machine code. Instead, it creates intermediate language, or IL. IL is a low-level architecture-neutral representation of your program. Think of it as a bridge between human understanding and machine execution. This IL is packaged into or exe files, along with metadata describing all types and structures. The beauty of IL is its portability. The same file can run on many platforms without recompiling. Use of intermediate language is what makes net truly cross-platform. IL files can be executed on Windows, macOS, or Linux thanks to the architecture-neutral design. This means developers don't need to rewrite or recompile code for each operating system. Instead, the same IL file adapts to different environments, making net practical for real-world multi-platform projects. This flexibility is a major reason why net is favored by developers aiming for broad compatibility. Once you run your compiled program, the Common Language Runtime, or CLR, takes over. The CLR is the brain of your application during execution. It loads your IL, checks for safety and validity, ensuring type safety and memory safety, and prepares everything for execution. This validation step is crucial, preventing many runtime errors that unmanaged languages often face. Thanks to the CLR, developers rarely need to manually manage memory, making development smoother and safer. CLR's validation process might seem invisible, but it's essential. It checks your IL for type safety and memory safety, ensuring that your program won't suffer from common errors like buffer overflows or invalid memory access. This layer of protection is what makes net applications robust and reliable. Developers can focus on building features, knowing that the runtime is guarding against many low-level pitfalls. This is a key advantage of managed environments like net. If you like my channel videos, subscribe my channel for more videos. How comes the magic, just-in-time, or JIT compilation? The CLR passes your IL to the JIT compiler, which converts it into native machine code, actual instructions the CPU understands. This happens method by method, only when needed. Your program isn't compiled all at once. Instead, each piece is converted as it's used. This approach allows net to optimize code for the specific operating system and CPU, balancing portability with performance. JIT compiler doesn't just translate IL to machine code, it also optimizes it for the specific hardware and operating system. This means your application can run efficiently, taking advantage of the unique features of each platform. By compiling only what's needed when it's needed, net ensures that your code is both portable and high-performing. This dynamic approach is a cornerstone of modern software execution. While your code runs, the CLR provides a suite of runtime services that go far beyond simple code translation. These include garbage collection, exception handling, thread management, and security checks. Each service plays a vital role in making net applications reliable and efficient. The runtime handles complex problems so developers don't have to reinvent solutions, allowing you to focus on building great software. Managed environment provided by the CLR is what sets net apart. Developers benefit from automatic memory management, structured error handling, and built-in concurrency support. These features make it easier to write reliable, scalable applications. The runtime's continuous support shapes how your application behaves under load, handles failures, and uses system resources. This is the true power of net's managed runtime. Memory management is one of the most challenging aspects of software development. In net, the CLR handles this through garbage collection, or GC. Instead of manually allocating and freeing memory, the runtime tracks object lifetimes and automatically reclaims memory that's no longer in use. This reduces bugs and lets developers focus on object behavior rather than cleanup. The GC operates on a managed heap, grouping objects by generation based on their lifespan. Garbage collector uses a generational approach to improve performance. Short-lived objects are collected quickly, while long-lived objects are scanned less frequently. This prevents memory leaks and dangling pointers, making net applications more stable. Developers can focus on building features, knowing that the runtime is efficiently managing memory behind the scenes. This generational GC model is a major innovation in managed environment. Failures are inevitable in real systems. Files go missing, networks fail, and invalid input appears. The CLR provides structured exception handling to manage these failures predictably. Instead of crashing or corrupting memory, exceptions propagate in a controlled manner through the call stack. The runtime ensures resources are released properly, and catch blocks receive consistent error information, enabling clean recovery paths and defensive programming. When an exception occurs, the CLR safely unwinds the stack, releasing resources and ensuring that error handling logic is separated from normal execution. This makes code easier to read and maintain, and encourages developers to write robust defensive applications. The runtime's structured approach to failure management is a key reason why net applications are reliable in production environments. Modern applications rarely run on a single thread. The CLR includes built-in support for thread creation, scheduling, and synchronization. This enables applications to take advantage of multi-core processors, improving performance and scalability. Higher-level abstractions like the task parallel library and async await are built on top of these runtime services, making concurrent programming easier for developers. Runtime manages thread pooling to avoid the overhead of constant thread creation and destruction. It also provides synchronization primitives like locks and monitors, ensuring thread-safe access to shared resources. This allows developers to write scalable, concurrent applications without dealing directly with OS-level threading complexity. The CLR's thread management is a foundation for modern, high-performance software. Type safety is one of the most critical runtime services, though it's often invisible. The CLR ensures that code accesses memory only in valid, well-defined ways. This prevents illegal memory access, buffer overflows, and type confusion errors that commonly lead to security vulnerabilities in unmanaged environments. Before execution, IL is verified for strict rules around type usage and memory access, and these guarantees remain enforced at runtime. CLR's memory protection model allows net applications to run with greater confidence, especially in large codebases where manual verification would be impractical. By enforcing strict access rules, the runtime prevents common vulnerabilities and ensures that your application remains stable and secure. This is a major advantage for developers working on complex, mission-critical systems. CLR also enforces security boundaries, ensuring that managed code executes within defined permissions and constraints. This is especially important when loading third-party libraries or executing dynamically generated code. By mediating access to sensitive operations, the runtime helps reduce the risk of unintended or malicious behavior. These checks are often invisible, but they contribute significantly to the stability and trustworthiness of net application. Even as modern net relies more on OS-level and application-level security models, the runtime still plays a crucial role in maintaining managed code safety. By enforcing permissions and constraints, the CLR ensures that your application operates within safe boundaries. This is especially vital when integrating third-party components or running code from untrusted sources. The runtime security model is a key factor in net's reputation for reliability. Chash to CLR to OS pipeline isn't just a technical detail, it directly affects how applications behave in production. Garbage collection impacts latency, JIT compilation affects startup time, and runtime services shape how concurrency and failures are handled. When developers understand these mechanics, they stop treating the runtime as a black box and start working with it, leading to better performance tuning and safer design decisions. Understanding the net execution pipeline gives developers a competitive advantage. It enables better performance tuning, safer design decisions, and more predictable systems. By knowing how garbage collection, JIT compilation, and runtime services work, you can optimize your applications for speed and reliability. This knowledge is especially valuable at scale, where small improvements can make a big difference. The more familiar you are with how net executes your code, the more confident and effective you become as a developer. Predictable systems are easier to maintain, debug, and scale. By leveraging the runtime's features, you can build applications that handle load gracefully, recover from failures, and use resources efficiently. This predictability is a hallmark of well-designed net software. When you understand the inner workings of the net runtime, you gain confidence in your development process. You can anticipate how your code will behave, optimize for performance, and design for reliability. This knowledge empowers you to make informed decisions, avoid common pitfalls, and deliver high-quality software. The net execution pipeline is your ally in building robust applications. Let's recap the journey. Chash code is compiled into intermediate language by Roslyn, packaged with metadata, and loaded by the common language runtime. The CLR validates the IL, manages memory, handles exceptions, and provides concurrency support. Just-in-time compilation transforms IL into native machine code, optimized for the current platform. Runtime services ensure safety, security, and reliability throughout execution. This pipeline is the foundation of net's power and flexibility. Understanding the net execution pipeline isn't just academic, it's practical. It affects how your applications perform, how they handle errors, and how they scale. By mastering these concepts, you become a more effective developer, capable of building reliable, high-performance software. The runtime is not a black box, it's a powerful tool that shapes your application's behavior and success. This knowledge is just the beginning. As you continue to explore net, you'll discover even more ways to optimize your code, handle complex scenarios, and build scalable systems. The execution pipeline is a foundation for advanced topics like performance tuning, security, and concurrency. Stay tuned for deeper dives into Chash programming and net architecture in future videos. As a developer, understanding the net execution pipeline helps you write better code, debug more effectively, and design safer systems. You'll be able to optimize for performance, handle errors gracefully, and leverage runtime services to build robust applications. This practical knowledge is a valuable asset in any real-world project, making you a more confident and capable developer. Mastering the net execution pipeline gives you an edge in software development. You'll be able to make smarter design decisions, optimize for speed and reliability, and build applications that stand out in production. The runtime's features are there to help you succeed, and understanding them is the key to unlocking their full potential. Keep exploring, keep learning, and keep building great software. Summary: the journey from Chash code to CPU execution is a marvel of engineering. The net execution pipeline transforms your ideas into powerful, reliable software. By understanding compilation, runtime services, and native execution, you gain the tools to build better applications and become a more effective developer. The power of .NET lies in its managed environment, cross-platform flexibility, and robust runtime services. Embrace this knowledge and elevate your development skills.